y equals x to the 5 minus 5x to the 4. We're asked to find dy by dx and d2y by dx squared. So remember, we've got our rule. If y is equal to k x to the n, then dy by dx. We bring the power down and reduce the power. Just leave the k in there. nk x to the n minus 1. Not going to prove this, but you can do using first principles. Here, we're going to get 5x to the 4 minus 20x to the 3. And then for the second derivative, we just differentiate again. This is going to give 20x to the 3 minus 60x squared. Verify that the curve has a stationary point when x is equal to 4. So you could solve dy by dx equal to 0, but it's going to be much quicker to just sub in x equals 4. When x equals 4, dy by dx is going to equal 5 times 4 to the 4 minus 20 times 4 to the 3. And this ends up being 1,280 minus 1,280, which gives 0. Therefore, or I'm just going to say the result follows. We can say, therefore, the curve has a stationary point when x is equal to 4. Determine the nature of the stationary point. So for this, we can use the second derivative. So now 20 times 4 to the 3 minus 60 times 4 squared. And that ends up becoming 320. This is greater than 0, and that means it's going to be a minimum. Just a little reminder why that is. So when you have a minimum, the gradient is actually increasing over the course of the turning point. So that's why if we get positive, a second derivative, then it's a minimum. But for a stationary point, that is. Whereas for a maximum, the gradient's actually decreasing. So the second derivative, which is the gradient of the gradient, would be negative. And if it's 0, then the method fails and we have to look either side. So don't forget that, because that it's not often used, but sometimes it comes in. So you would look at the gradient just either side of the turning point. Well,